Hello everyone. Thanks a lot for being here. Sorry for all the mess in this place. It is 6 a.m. in Australia now, so I'm recording this from home, and I'm super excited as well to give you guys an introduction to Phaser and to create a little game and show you as well a bit of the workflow how you can create these cross-platform games and test them on devices. So let's start from the very beginning. Phaser, which you can learn more about on phaser.io, is a cross-platform game development library in JavaScript. It's open source, it's free, it's being used on several professional games, such as game for the Lord of the Rings and a few other games on the BBC website and Nickelodeon website. And so there's a really good collection of games here on their website. I think I'm just showing the mobile version, especially if you go to I think it's news or learn, and there's a section with a selection of featured games, which is quite interesting. So regarding this talk itself, I wanted to make it interactive, and usually on these sort of events, sometimes the game development part is a bit of a relaxed area and a bit more playful. So I've put a repository on GitHub, which is Farias slash Phaser dash createconf, as you can see, and I've included here a small platformer game, but that includes a lot of the important concepts that are important in Phaser. So main-final is a final file, but I've created like a starter file for you guys to work on if you want to code along. If you don't want to code along, feel free to just watch, and you have the final file anyway. So let me get back to this. If people have questions, I've never used this system before, but I'll keep an eye if people have questions, and I'm sure Josh will let me know as well. So what you need to all right, cool. So what you need to run Phaser games is obviously a code editor, and I've included the Phaser library already on the repository. I'll leave that on for longer. And also you need a local web server to run the games, because the loading of the files and the loading of the assets, which could be level files, audio files, happens asynchronously. And as you probably know, you're not allowed to load files asynchronously from your file system. If you actually could do that, the web would be a very dangerous place, as you can imagine. So you need a web server. It could be a local web server, remote web server. A really quick way to have one working for you is to look for a Chrome app called 200OK web server, and then you can specify a file. So I'm doing that at the moment, and it's basically a black screen what we have now. How does Phaser show anything on the screen? What does Phaser use for rendering? There are mainly two options. You can use WebGL, or Phaser will default back to Canvas if WebGL is not available. This all happens thanks to a library called Pixie.js. Phaser is built on top of Pixie and uses Pixie as the renderer. There's also a headless mode, so if you can run Phaser games without rendering on the server side, for instance. So there's that option too. So let me guide you through the basic structure of our project. We have index.html, in which I'm including some viewport tags that relate to disabling scaling on devices. Just the magic here is that games work everywhere, including the Phaser library, and also just adding some really quick sort of styling, so that I like it better when it's a black background. I think the game looks a bit better, and you can include your JavaScript file. So after I show you this game, I'm also going to show you bigger projects to see how you can organize your folders and your code in a different way. This is just the simplest thing you can do. So then if we go to the JavaScript library itself, I've actually included some information and discount code for the participants of the conference for some of my some of our video courses. So you can look at that as well. And the main thing here is that we start by creating a Phaser game object. So you go new phaser.game, and you give it dimensions for the screen. In this case, I had this from a previous example. And in here, you specify the type of rendering you want. So you can set it to auto, which means it will use WebGL if available, and if not, it'll use Canvas. But you can also force it to be Canvas if you want. The other place that I forgot to mention is the documentation of Phaser, and also examples of phaser.io and the documentation. So I might have to look at this if I forget one of the parts that I was supposed to write. So this is where we define the framework, and then what all the action takes place in what are called states. A game, think of a game as multiple states. You have a loading screen, then you have a home page on the game, a main page, then you can have the game itself, then you can have maybe a shop or a pause screen with some other features. For each screen of your game, for each main part of your game, you create a different state. You can also create a game that's a single state, such as the one I have here. So for that, you have to create a different object for each state, and that's just a JavaScript object. And I'll show you in a second what that object usually looks like. And you give it a key so that you can refer to it later. This doesn't have to be the same name as this. It can be anything you want, but you need to be consistent as when do you refer to this. So all we're doing here is telling Phaser, okay, we create a game, and now this is this game state, this object here that I'm going to show you, and now open that up, get that state open. That's where the game would start. So this is what a simple state looks like. Actually, the only thing you really need if you want to display an image are preload and create. So states, as you see, is just basic JavaScript object, and it can have an init method. Anything that you put in here would have to do with game settings, some game parameters like screen, scaling options, and things like that, which I'm going to show you. And that only gets called once before everything else. After init gets called, preload gets called, and this is where all the asynchronous file loading takes place. So in here you'll be loading all the images, all your JSON files with game data, audio files, and when that process completes, when all the files are loaded onto the memory of your web browser or web view or whatever you're running this, the state method is called once. Sorry, the create method is called once. And this is where you would create your sprite. So you loaded a bunch of files, but they don't have any properties. And now you actually create a sprite which will have which can have scaling, rotation. In here you can create some groups, some collections, and call a few initiating methods. And then we have update, which is called multiple times per second. So in here is where you would run checks on your game that have to be taking place at all times while this state is on. For example, collision detection will take place here because that's something you always want to be checking for. If two elements overlap or if two elements collide, you want something to happen. Also, when the user presses a certain key on their keyboard, you want to be able to check that at all times, so it will go and update. Besides these methods, there are a couple more reserved methods which you can find on the documentation. And also, what you do next is, as we build the game, we'll add our own methods here too, just to keep everything in one JavaScript object. Now, if you give me 5 seconds, I have a cheating guide that I printed that I just need to quickly fetch. So give me 5 seconds. Okay guys, sorry about that. So what I'm gonna do now is talk about sprites and show you how you can load some images. So let's look at some of the images that are already present here. We have a folder called assets, and then I just want to check if there's some questions or some comments. Okay, and then we have 2 folders. One of them is called data, which has a level file that will load later. and then another one that has images. And then we have a few images like a little barrel. This game will look like Donkey Kong, by the way. And I should have probably started by showing you the final game. But as I mentioned, it's 6 a.m. so I'm slowly starting up. And then we have fire, we have a gorilla, and we have a player that's a sprite sheet like this. So we also have ground and platforms. And then I'm also gonna show, I'm not gonna type that live, but I'll show you as well how to add also touch buttons on the game. So let's begin by showing a sprite. The first step is to preload the file. So for that you type this.load, which gives you access to a loader object that's part of Phaser, and then image. And now you have to give your image a key. It can be any arbitrary key that you want, but you'll have to be consistent with that. I usually just call them the same as the file name, but that's not always the case. It doesn't have to be. And then you specify the either relative or absolute if it's a URL path to the asset. In this case, assets, images, and this is called ground.png. So I've loaded the image. Now, for this to actually do anything, I need to create a sprite. So the other Chrome extension that I'm using here is this live reloader, so I don't have to save the page. I don't have to press F5 when I save. So you might see things appearing there. Okay, so now that we have the image loaded into memory, we can create a sprite, and I'm gonna put this sprite on the context because I'll be accessing it later from a different method. So this.ground is gonna be a sprite, and to create a sprite you simply do this.add.sprite, and then you have to give your sprite coordinates. The coordinates system starts on the top left corner. So in this way is positive on X and downwards is positive on Y. We'll place this, let's say 0, 6, 3, 8, because I magically happen to know that that's where I want to place it, right? So if I save that, there's some error here. I'm not sure if this is. Let me place it in a different position. There it is. Yeah, I just haven't set the size of the game world just yet to place it so far down. So, for example, if I put it in 200 instead, it moves down. So that brings me to another important concept on Phaser, which is that of anchor points. The point that I'm actually setting the coordinates to is the top left corner of this image. But what if I want to place it by the middle? Because sometimes that's what you may want to do. For that, you need to change a property called anchor, and then you can either set X, Y manually, or you can use a method called set2. And if I set it to 0.5, this is the same as setting it 0.5, 0.5, basically the middle on both X or Y. And I'm missing an N in there. So there you go. Now we're placing it by the center. We didn't really want to do that, but I wanted to show you what that part was about. Actually, I'll leave it there because I'm all going to show you a couple of more sprite tricks, and then we'll jump into the game. Because these are basic skills that you'll use in all sorts of games. So something else you can do, what if you want to change the position? Super simple. Just change X or change Y, and you're moving it somewhere else. If you want to change the size of this sprite, you can use the scale property. And you can set the scale on both X or Y. If you want to leave the scale the same, you simply type 1. So let's say that we want to scale twice the size on Y, and then that'll give us something like that. What if I want to shrink my sprite on X instead of increasing it? Then I can increase it to half the size. So that's quite cool. Now, what if I want to flip my sprite? So let's set the scale back to 1 to show you what it looked like. What if I want to mirror this on X? I don't want to change its size. I just want to change its mirror now. So I think it'll be more clear once I save it back again. So see how that part was there, and now it's on the other side. So those are things you can do with scaling. And then the other thing you can do is change the angle. For example, 60 degrees, and that is counted clockwise on degrees. What if you're not an angle person? If you're more of a radian person, you can also do rotation. It can be, let's do 1. And in that case, it would be in radians. And actually, this is a good not sure if that actually did anything. So if you want to, yeah, it did. So if you want to quickly see what update is about, let me show you that by making this rotate. So this is going to be called multiple times, so we can, like, if we want to slowly increase this, well, that was not going to be too slow, but you have to be this. I think I'm wrong with the Radian API. I think it's actually rotate. Oh no, this is what I was missing. +1. Yeah, there you go. So that's what update does. Anything that you want to be doing at all times, you have to do it in update. And then if the window is not active, it stops. Anyway, there's another way to animate other than update, which is called twin animations, which I might have time to show you as well. So now let's do something that will actually be part of the game that we're building. So I mentioned before that we were going to talk about screen scaling, and that's a very important concept on cross-platform games, because how should this game look when you're there? But what if you are using some sort of different browser size, a different device? If you're on a tablet, if you're on a portrait mode phone, Phaser gives you a lot of control for those cases. There are a few options for what's called the scale mode. So where the right place to set those options is on the init method, and this .scale gives us access to the scale object. So if you go to the documentation, and there is a scale property. There's actually a guide to scale manager, but that will give you some more information on scaling the screen. But as a quick mode, to scale mode, and Phaser dot scale manager dot this show all. Show all means that the screen will be fit to size, so that either X or Y touches the edge of the screen. In this case, because we're using a black background, it makes it a bit confusing. Maybe I should change that so that we can have a better view of what's happening here. So this is the game area, and as you can see, it fits on Y. But it could also happen that the device for some reason is different, and then we are actually fitting on X, and we have empty space on Y. But you're probably going to be asking me, okay, my game, I actually wanted to keep the aspect ratio, which is what we're doing here. But, oops, I was meant to close that. But I do want it to be centered, to be aligned correctly. So for that, I can just also do this .scale .page align vertically and page align horizontally. And in both cases, I can set it to true. Oops, I think the screen is interfering with some of the shortcuts that I'm used to occupying here. So let's just do horizontally, and now the screen shows in the middle. So that's a step. There are also other properties such as exact fit if you really wanted to match exactly. And if you actually search for Phaser virtual pet, or Zenva maybe, my company name, there's a tutorial that I wrote which explains with examples the types of screen scaling. So I'm just gonna quickly show you. Here it is. So you have all these options. You can have an exact fit, in which case the game will force to be occupy all the area, but then the aspect ratio won't be respected, so it will be distorted. Then you have show all, in which we're simply showing the game as I'm doing now. So we're occupying all. We're trying to fit in as much as we can without modifying the aspect ratio. And then you have no scale, in which it just shows per pixel value. So if you have a massive screen, the game will be tiny. And then you have resize, and there are more advanced options as well. A whole scaling API if you want to learn more about it. In resize, you will, if you have a bigger screen, you will sort of show more of the game. So that will be good for maybe top-down games where you have a tile world or something like that. So that's all for screen scaling for the time we have. And now I'm gonna show a couple of more things. I'm gonna show you the basics of the physics engine. So Phaser comes with two physics systems. A basic one called the arcade, in which every element is simulated as a rectangle, and then a more advanced one called the P2, in which you have more advanced properties and you could create something like Angry Bird or Cut the Rope. For the arcade mode is what we'll use, is what you would normally use in simple games, where you don't need collisions that involve angles or that involve multiple things. So let's start by initiating this physics engine. So for that we do this.game. It gives us access to the game object that we this is part of Phaser API. .physics .start system, and the system that we are initiating is called Phaser.physics.arcade. So, but just by typing that, we're basically telling Phaser, okay, there's going to be some physics here, but by default, it's not applied to all of the elements that you have. You have the control to manually apply, make elements have quotes like physics properties. So, so let me show you what happens if I physics enable that sprite that we created. So I'm going to go to create, and let me just find this. Okay, so we're going to create, and this.game.physics again, and arcade, because now we have that at our disposal since we initiated the arcade system, and we can enable something. And what we enable now is the sprite itself. So this.ground. So what happens now? I'll show you. This.enable, and there's something else that we have to do. Well, that strictly speaking should be enough to give it gravity. So I'm a little bit curious as to why it's not falling. Oh, of course, we have to define that our world will have gravity. So this.game.physics.arcade.gravity, and then we can set gravity on X or Y. So you can make a game that has gravity on X as well, or it could represent something like wind. So as you see now, our sprite is falling down. What if we wanted to stay fixed in the world? In that case, we set something like this.ground.body. As soon as we enable physics on a sprite, we now have a body object at our disposal. And in this one, we can do things like allow gravity equals false. And now it doesn't fall. So the other thing you can do is collision detection, but for that we need a second sprite. So let me add a second sprite, and I think after that I'll show you. I was thinking of typing everything, but it's a bit cold and my hands are kind of freezing. So there are parts that I'm going to copy and paste from the final one, so just so that we can do more in the time we have. So let's add a second sprite, and I'll show you how collision works. So for the second sprite, and then as I mentioned, I'll change that. We're going to actually reuse some of the same elements that we have here, but I'm going to place this one below, and this one is not going to have gravity, but the first one will have gravity. So ground 2 is not going to have gravity, and we are going to get rid of that line here. So as you can see, there's no collision by default. You have to specify the elements will collide, and for that you have to do that in update, and the way to do that is by calling this.game.physics.arcade.collide, and then you specify which two sprites are going to collide. And then you could also have groups, which we'll look at as well, so that you can specify that a whole group of elements collides with another group of elements or with a single sprite. So this.ground collides with this.ground2. So I want to show you what happens now. So see that they collide, but the inertia the momentum is passed to the second sprite. And we probably didn't want that when it's the floor. The ground should be something stable. So for that, you can set the property of immovable for the body. And if you set this to true, then it will not move even if it's hit by other elements. So that's actually taking us somewhere now. So before we move on further with physics again, I'm gonna go back to sprites and show you and talk about sprite animations. So as you saw, the player image is actually a sprite sheet. Each one of these images has the same separation, and they're all in a single image file, PNG, with transparent background. So I want to be able to play this animation and show you how you can play it as well. The way it works is that each frame has an index, so this is frame 0, frame 1, frame 2, frame 3, frame 4. And then you can specify, when you create your sprite, you will specify what index is the one that's going to be shown, and it will be 0 by default. So the first step again is to load the image, and Phaser doesn't care if this is a sprite sheet, if this is an image. You just load it here, and it is when you create the sprites, when you give it all the life, basically. So this will be our player, and the image file is called player underscore sprite sheet. So that will give us now we can create a sprite called player, and for that I need to now add the sprite. So let's create a player, this.player, this.add.sprite, and the location, let's give it somewhere in the middle. Let's put it on top so it will fall, and now we can specify that this is player. So by default it's showing all of them, and now we can specify which one we want. So we just want the first one. Oops. In the one part I have to specify that this is a sprite sheet, so I'm just looking which part I missed. Oh yeah, so my apologies about that. We actually do have to specify that this is a sprite sheet, and we do have to specify some of the properties of the sprite sheet. So the properties you have to specify are actually the width of each frame, because it's not going to know it by magic, and also the height of the frame, and also we have margin and separation between the sprites and between the edges of the image. And now how many of these do we have? Actually, that was the parameter here. We have 5. We have 5 frames. So now actually now is when we can specify the frame here, and it should give us that particular frame. you can also, so once you load the sprite sheet, that doesn't mean that the animation will necessarily be created for you. That you actually have to create your animation, and you're free to define how the animation is going to work, because imagine you could have an animation of the player walking, and then you could have something here where the player jumps, where the player ducks, or where the player dies or shoots a gun or something. So you could have all these different animations here, and you can create animation objects for each one of those sequences. So the way to do that is by doing this dot player dot animations dot add. So this animation, let's call it walking, and it will involve the following frames. It will involve frame 1, frame 0, frame 1, frame 2, and then frame 1 again. So that's just how I want to define my animation. And they occur at a rate of 6 frames per second. And I want this to, I forgot what the last parameter was. Let me just quickly look at it. Sorry, we have to play the animation for it to actually take place. I think the animation has the back has to be, oh yeah. So the true at the end is the order is the reverse. So it will play like so: 0, 1, 2, 1, and then it plays 2, 1, 0. So it goes back, but just once. And now to actually play this animation, we call play. Oh, sorry, this is the auto loop option. That's what it is. That last parameter is the auto loop option. So now we're playing this animation and it goes on forever. But if you set this to false, it plays just once. This would be, for example, if you want to play the player dies, it'll just play that. Okay. We do want our walking animation to always be playing. So that's how you can play. That's how you can do simple sprite sheet animations. And the other concept that I wanted to talk about was that of groups. So and also the level data, how you load the level data, and how so we're going to start actually by sort of simulating that level data. So let's say that we have a group of platforms in our game. So this platforms will be this .add.group. This gives us an empty. A group is basically a placeholder for sprites that can be used in some occasions as if it was a sprite. For example, you can change the X and Y of the whole group, or you can check collision between the whole group and a single sprite, or the whole group and another group. So you can enable body, as in enable physics, like this, on the whole group from the start by just typing in the name of the group, and then enable body equals true. So provided that your physics engine is loaded, this will make it so that the whole group can have collision. Cool. So now how do we add elements to this group? It's actually quite simple. We can do this .platforms .create, and then we set the coordinates x and y of this element. For example, it will be located in 50 and 150. And now what sprite are we using? Let's say that we're using ground again. So that should already be showing our ground. So we created another ground in there. We can add more of this. So I'm not using the duplicating keyword because it's interfering with something that's on my screen at the moment. So we could put this in a different location and have all these platforms. What if we want them to be immobile? One cool thing about groups is that you have this set all method that allows you to set the value of a whole property, and you can even go in nested levels. So we want to set body.immovable to true for the whole group, and we also want to disable gravity for the whole group. So allow gravity is going to be false for the entire group. There we go. So we could also check collisions in the same way. And what I'm gonna do now is actually go through the final code of the game and explain some missing bits and pieces. Show you how to use the keyboard, and then I'm gonna show you a version of the game that has on-screen keyboard. And then I'm actually gonna let you guys decide among a few options as to where we head next. Okay. So the final game. What I'll do here is just copy and replace this stuff, or maybe just change it to main dash final. Let's refresh this. There we go. So as you can see, we've got a mini, and I made some changes last night, so I probably broke it. So it should probably show you the, let me see if it's something quick, or otherwise I'll show you the other version. So I can now set property must jump. Let's look at that, 147. Yeah, so forget about that. Yeah, that should work now. Yeah, there we go. So we've got a simple kind of Donkey Kong game. You can probably imagine already some of the things that are being created here as groups. For example, the platforms, the fire, the barrels, and also I'll show you how the level data is loaded. So let's start from top to bottom and just cover everything that we've been looking at and just fill in any gaps that are there. So we started the game. We initiate our game level settings. We set up our screen size, our screen scaling options, alignment option for the screen. We initiate the physics engine, and this is how we can activate the keyboard. We don't want the entire keyboard. We don't want to be listening to all the keyboards. Too many event listeners for no reason. So all we want is the cursor keys, and this is a way to initiate the cursor keys. So you remember that before we tried to place the platform way below, and it was outside of the world, so it wasn't created. There's something called world bounds, and this will help us, for example, so that the player doesn't leave the screen. So then there's a couple of constants, as in running speed and jumping speed. If you change those, it'll be pretty funny. You can make the character jump higher, jump lower. And actually, I haven't mentioned it, but all the assets of this game were created by us. So the license of this game is do whatever you want. All right. So if you want to modify this and turn into a full game, put it on your website with more levels or anything, feel free to do so. And if you do so, actually let me know, because I love to see how people change things that we teach. So we're loading all of our assets. All image loading section should be pretty familiar now. We're loading 2 sprite sheets, specifying the properties in both of them. If you get confused like I did with the parameters, there's always the documentation. I never normally code without the documentation. Even when I make video tutorials, I have another screen with everything already done for me. So with the documentation or any cheating or the whole game actually finished. So this is something new. I said this is where we load assets, and assets are not just images. So we can also load text files. In this case, we're loading a text file that's level data. The format of this level data is entirely arbitrary. It just needs to be a JSON file. This is just the data that how I decided to organize it. You can do it differently. So what things did I define here? The start point of the player comes from this file. The position of each platform, X, Y, the position of each fire, the position of the goal, the gorilla on the top, and then the frequency of barrels and the speed of the barrel. So you could make this game much harder if you increase the speed or the frequency. And you can change the position of anything here. So all we're doing here is just loading that. Phaser doesn't know what this is. It doesn't know what it's for. We still need to parse the JSON using simply json.parse. So if you have any errors on your JSON file, that's probably going to make the game crash. So you might need something. Also, this, as I mentioned before, all of these URLs, all of these can also be absolute URLs. So you could be loading your JSON file, could be coming from a server. You could create your levels on your server and load them from here. You could use something like Firebase and create your own levels and share them around. So possibilities are endless, and one of the main mantras of Phaser by the Phaser creator, who's Richard Davey, is that Phaser is to create explorers, not necessarily experts. So it's one of the great things about Phaser is that it's just so easy to go and change things, and then you start playing, and then the whole day is gone, and you didn't get much done, but you had a really good time. Okay, then moving on, we create the ground of which in this case have hard coded the location, but yeah, you could also load it from the external file from a server. So I'm gonna keep on repeating that. Possibilities here are endless, and this is just JavaScript. So you can integrate this with whatever you want. This is how I'm parsing the level data. So this is how I access it. Game.cache, get text, and it gives me the string with all the text, and then I parse it. I think I'm under the understanding that sometime recently there was a JSON loading, in which case you don't have to do this, but then again, this doesn't really do any harm. So there might be some upgrades. There's always new features, and I'm not necessarily up to date with all of them. So but then again, I'm using the latest version, as in like this week actually. So it all works. We're creating our group, enabling body, and then I'm just iterating through our level data and creating a platform for each one of them. So I'm doing this we're using a for each loop, setting them all to fix on the screen. Similar thing for fire, but for fire, I'm also creating an animation for each one of them, and I'm also playing them. And then I'm also setting them all so that they don't have gravity, they don't fall. But they are, strictly speaking, they are not immovable. The goal of the game, just a simple sprite. The player itself, just a simple sprite. I did set the anchor to 0.5 for some reason here. And I set this property so that it can't leave the bounds of the world, so that it's restricted. Otherwise, you would come off the screen. This is interesting. This is how I set the camera to follow the player, so that so that the game scrolls and the player is always followed. For the barrels, I created just an empty group, and then I'm using a timer loop that runs every frequency of barrels times second. This is a constant that you can use here, but I think if you enter 1000 it works too. And what I'm doing every 5 seconds or every X seconds is calling this method, create barrel. So what does that method have? Create barrel. It basically checks that we are checking that there's a barrel that's dead, and if there's no barrel that's dead, basically that's out of the screen, we create a new one. But if there is one, we actually reset it. So this is called a pool of objects. We're basically reusing objects, so we don't create unlimited objects and end up with a memory leak and our game all of a sudden shuts down. So then we set the velocity, and then the last part is just the update function. So we've got collision between the player and the ground, the player and the platforms, the barrels on the ground, the barrels on the platform, same thing with the fire. But now we've got also callbacks. So overlap, the difference between collide and overlap is that on collide, the two things actually, the bodies crash. So as you saw, the momentum gets passed along. Whereas in overlap, I haven't heard from you guys in a bit, so I'm just checking that you're still alive. So apparently we're still alive. No, I'm not using the autumn plugin that's for Phaser. It's not that smart, sadly. It's because I already have a final version. That's where it's getting all the hints from. Okay, so let me keep this closer. Okay, sometimes I worry that I'm just speaking alone in this universe and everyone else is dead. So the difference between these two is that collide actually the one body influences the other body, so they will both move, for instance, or one of them, the velocity will stop. Whereas overlap, nothing happens, as in the velocities don't change. but we still recognize the fact that they are overlapping. We acknowledge that, and we have a callback. In this case, kill player or win game. What do those look like? Very simple. Just ouch and restart the game state. Same thing when you win. Alert, you win. Obviously, you could have another state and more something else happening. And then regarding the actual platformer dynamics, we're checking that if the buttons are pressed, we are basically modifying the speed of the player, and we're flipping the player. As I already told you at the beginning, how we can flip a sprite without changing the scale by using minus. We're doing exactly that. And also, if the player is not moving, so if the cursor is not being pressed, we stop the animation. And this is how we're handling jumping. And then regarding the barrels, when they leave the screen, when they leave certain properties, and these properties, yes, they could come from a level file or from the server, we kill them. This is the right way to kill a sprite, because it still leaves like a ghost of the sprite that we can then reuse on this sort of stuff, and it doesn't break the game. If you use another method called destroy, which used to be used more in the past, it would actually break your game. So beware if you see destroy in a tutorial. It might be a bit old, it might break, it might cause some problems in your game. So just to keep my promise on the on-screen touch control, and we only have 10 minutes, but I guess another 5 maybe, since we started 5 minutes later. Regarding the touch controls, I'm just going to quickly show you what that looks like. It's basically the same as you've seen so far, but we're loading images for those buttons, and then we had a method here called create on-screen controls, and the on-screen controls simply are sprites that are being positioned in some part of the screen, and they have this property called fix to camera, so that when you scroll, they stay in the same place. We also set the alpha so that they're a little bit transparent. And then this is how we listen to click events or touch events. Same thing here. It works for both. You just any sprite dot events dot on input down add and then callback. It can be a callback right here, or it can be obviously passing a method or something else. And in here I'm just setting flags, as in should the player be jumping, should the player be moving left, should the player be moving right. And then when the player, this is when the input is up. So this is when we press it, and this is when we release it. So we set the properties, the flags to true or false. And then on update, it's the same as we just did, but we are just checking for keyboard or the flag, so that this works both on a desktop or on the mobile. So I wanted to ask you now, what should I do next? Option 1 is taking a look at the Intel XDK to complete that part. Option 2 is just show you more games, different games that have other stuff, like maybe multiple states or things like that. Is it possible to add the first game to mobile app? Yes, and that's what that's what I can cover on the hybrid. So I don't know if there's like a really easy way here to create a poll and get an answer in literally like a minute or 2 minutes. Is that possible, Josh? Okay. No polls for speaker to answer. So maybe if it just says more games or Intel XDK, and in the meantime I'm gonna respond the question. So the question was, oh yeah, the first option would be more games. Second option would be show the Intel XDK to deploy to hybrid apps, as in native platforms and testing on the device and that sort of stuff. So regarding mobile, the answer is yes. So this all occurs in HTML/JavaScript/open web technologies. So that can go on a web browser, or it can go on a web view, which is a native element that exists on Android SDK and also on iOS, which is basically like a web browser without any menus, without bookmarks, stripped out of all these features, so that it just renders HTML, CSS, and JavaScript. So there's an open source tool called Cordova, which allows you to pack a HTML app like this into a native app. And it also exposes some native APIs, so you can have some things like access to contacts on the phone or notifications, and a lot more features. So that's the answer is yes, and it'd be using Cordova. Now, how do you use Cordova? Two main options. You can download Cordova running on the command line, Or you can also use a tool like the Intel XDK, which basically compiles in Cordova for you in the cloud. If you choose to download Cordova on your computer, you also have to download your Android SDK and your iOS SDK. That also means that you need an Apple computer to run the iOS SDK. And then on the command line, you'll do things like build, you'll do things like send to the phone, and you'll be using all the native toolkit from there onwards. If you're using the Intel XDK, the building aspect gets built on the cloud. And there's also an app so that you can test your app on the phone. It gets downloaded into this app, and then you can run it. That you don't have to use the Intel XDK to build stuff. To build stuff in the cloud, you can just use the testing feature, and the testing feature is also available as a standalone thing. Then what I've used as well for hybrid apps, but I know someone mixed it with Phaser, but it's also HTML. Basically, it's Ionic, but then you would have to, it would need to be a game inside of an Ionic app or something like that, and they would have something similar. But yeah, I wouldn't use something like that unless I want to use Ionic on that project. So I think the poll is already has 2 votes. So we're only going to wait 1 more minute to decide. So what I can talk in the meantime is that the SDK is the Intel SDK is a free tool created by Intel that allows to it facilitates a little bit the creation of hybrid apps. A hybrid app, as I mentioned, is an app built with HTML with open web technologies that is packed together as a native app using Cordova. And okay, so XDK has won the poll. So I'm gonna launch that. It's free and it works on all operating systems. We actually yeah, so this is loading now, and it's basically like many apps in one. It's kind of a bit of a monster in that sense. You don't have to use most of it. You can use a couple of the things that are available. For example, it comes with the brackets code editor, but I personally prefer to use Atom, or maybe I'll want to use something else. So and also I like to have like many projects open at the same time, not work on a single project. Especially if I'm doing anything with Phaser, because I just copy and paste stuff from all the examples and the games. But some of the good features are indeed the remote and the online building is as well easy. So you can start a new project. No, let's not do that now. Start a new project, and it can be a project that will use Cordova features, or it's just standard HTML. So you probably want to do the Cordova one. So not sure if I'm missing something here. So I'm gonna go to start new project. Yep, start new project. I think there's something that's not showing on my screen, like some button over here. Let me see if I can. That's really weird. Okay, as for some reason I'm missing something here to be able to actually start the project. I don't know if it has to do with, maybe I can just make it larger like this. That's very strange. Very strange. Well, you can also do import your HTML code base, in which case I'll just do that. And so you can import an existing app, or you can create a new one from scratch. And this actually comes with a Phaser starter. I'm not sure how updated it is, so it's also good to look at that if you want. But I think I don't like some of the folder structure that they have, and it's kind of rigid. So I usually just import the files. So okay, we've imported this. Continue. And let's call this Creator 2016. And so in here we say yes, we'll want Cordova plugins, and this I normally said no, but if you say yes, it gives you like just like an easy way, like some snippets. Somebody was asking about snippets. So you've got all these different tabs here. The first one is just a code editor. The second one is called the Ripple Emulator. This can also be downloaded as a standalone Chrome app. And it's sort of like the mobile developer tools. So it's sort of like this, like if you go to your game and you were to run the development tools. But the additional thing it has is that it also has some simulation of some Cordova plugins. Like if you want to pull some, or you can, for example, set a fake geolocation and it will assume that that's the geolocation. I think it's downloading something now. So this is kind of like the development tools that you can have here as well. You can simulate a Galaxy phone or Nexus, and you can simulate the touch screen. So it's kind of like that. So it's loaded now, but it also has these other things. So you can manually trigger some Cordova events. So it can come in handy for some situations: accelerometer, battery status, things like that. This is not a real simulation of device. This is really, I mean, it's not emulation. It's just a simulation. So sometimes it doesn't work too well. And then this part is actually quite useful. So you can push your files to a testing server for free, and then if you download an app called App Preview, you can run your game on your phone right away, and you can debug it as well. So that you can see if there's any errors. You get something. You can also do that without the app itself. You can just no, actually this also works with the app. So you connect your phone via USB, and it will show you the same console that you see here, basically Chrome's console. You will see Chrome's console in there, so you can change things. You can see any errors. It comes quite in handy. This is used also to do the profiling of the memory on CPU. And then this is also interesting part, how you can upload things to the cloud. So basically what this does, it sends your files to some Intel server, and it creates the build for you, the binary for your phone, or the APK file, and then you download the APK file. And for iOS, it does a similar thing, and then you can upload actually to the store. But at one point, I think I remember, you still had to generate certificates from the Apple website, put them here, and I remember that at the end I did have to use a Mac computer, but just for one step at the very end. And this publish part I haven't really used. I guess it can help you with some metadata. So that's, I think that already gives you like a starting point as to what this tool is and how you can use it. I don't know if we have a couple of minutes if to show maybe one more example really quickly, like some other game. I'll do that. So let's choose a different folder, maybe like a 5-minute max. I don't know, is that okay? Okay, all right. So okay, yeah, all right. I'm thinking which one would be like a quick sort of fit. Maybe just something that is also simple, but that has like something else that we haven't seen, like twins and switching between states, and a bit more on the text, showing text on the screen. So let's try this one. So this is just a farm animal game. It's like a children game where you just change animals, and each animal has an animation. So the way that game works. It's called Farm Animals Text. Oh, I thought I had a multi-screen one. Okay. So yeah, I think I'll explain twin animations, and that's how we move these elements like that. So the animation that we did before was really sprite animation, and we also changed the velocity of a sprite. But another way to do animations is called a twin, in which you change a property of the sprite. So you've already seen that sprites have properties like X, Y, or the scaling, things like that. So to create a twin, you basically you can give it a name like that, like put it in a variable, this.game.addTwin, and you put your sprite in here, and then you set what's the end of the twin. The end of the twin, let's say it's going to be change the X property, but you could put any property of the sprite here, anything. And how long is that going to take? 1 second. What happens when it's completed? We can set some other, this is optional, of course. And then when you want it to actually start, you call it like that. So in this case, this is for a new animal. A new animal is located off the screen, but it's new. X is the center of the screen, and actually this is a quick way to get the center of the screen. It gives us access to a game object and a world object, and that has a center X property. And so that's how we're bringing in the new animals. Whenever the user clicks here, we're bringing in a new animal, and we're also getting rid of the current animal. So that's another twin animation where the ending of X is some end X variable, which I think is some. So it's based on the current width, but it's really off the screen. And then we're starting that. So every time that the user clicks on these arrows, we are. So the ending of the animal is calculated because it could be either on the left or the right. But basically that's how twins work. So you say, I want to change the scale of my sprite or the angle of my sprite, and I want that to occur over 2 seconds. So I create that as a twin, and then something happens and I call it. And on the phaser example page, there are many options. You can have also specify if it's going to be a linear change or if it's going to be like the easing. There's different easing functions, or you can even create your own easing functions for that aspect. How can we show text on the screen? That's also very simple. This.game.add.text, and you set the location of the text, and you can also set the anchor point of your text. I usually set it to the middle in some cases, and you give it a style object. And the style object is pretty much like CSS, although this is not CSS. This is all being drawn on the canvas, but it's kind of similar to CSS. Then what the last thing actually I'm going to show you is on this game is the sounds. So we're loading audio in this way. We have to specify an OGG and MP3 file in an array because some browsers can't play one or the other. So with those two, you're always fine. And there's a free program called Audacity, which you can use to convert them from one to another or to even reduce the size by reducing the bit rate of the image. And then how we create that. So we've loaded it, and it's a similar approach than the sprite. So somewhere here there's some game. Let me search for sound. That's where we load the files, and then this is where we create the. Whoops. Oh, sorry, I have to search for audio. This.game.add.audio, and then you specify the key of your audio asset, and then just play. You just call it and say play. So that's about it for the basic games. So if I just wanted to show you where you can look at some tutorials for Phaser. So in our blog Game Dev Academy, if you go to tutorials and then Phaser, we've got dozens and dozens of written Phaser tutorials. Like for example, how to procedurally generate dungeons, pathfinding, how to create a turn-based RPG. So for all of these games, all of this content is free. These are all written by either me or other authors. So they've got, some of them have like Creative Commons copyrights. We always make that clear. You can download the source code, and they've got all the explanations and screenshots. So that's where we have our written tutorials. And then we also have, which is what keeps me off the streets. Thanks to a Kickstarter campaign, I created this game, this course, which teaches how to create 15 mobile games using Phaser. So you already saw 2 of the games. This is like a Crossy Road, JavaScript. Then there's the Animal Farm that you saw, a Virtual Pet. This is the basic platformer. Then we've got a spaceship game, an Infinite Runner, another platformer game where we use Tiled to create the levels. Tile is a free program that you can find at mapeditor.org. And then the other games that are Plant vs Zombie defense game, RPG game. This is using another physics engine, Angry Birds, town simulation game, match 3 game, point and click adventure, hexagon tile strategy game, and dungeon crawler, infinite randomly generated dungeon crawler, and chapters on app monetization using Cordova, and ads as well. So you can learn more about if you go to academy.zenva.com. This is the free program to create levels. It's open source as well, and it works also for Unity. It's used on many different game engines. So I think that's all. I'm happy to respond questions if we have time. Let me see if there's any questions here. Questions and topics. Oh yeah, more things here. Will you be adding the code you showed us today to the GitHub repo? Yes, sure. I'll add both. How do you handle users accounts? Yeah. So for that you need to. So let's make something clear regarding Phaser. Phaser is a tool to create and render 2D games on the browser, but we're still on JavaScript ecosystem. So you can also do Ajax calls. You can also integrate with your own backend. You can have your backend built on any technology, or use a third-party backend like Firebase or any other option. Maybe it could be tied to Ionic, native script, or React. Yeah, so you don't have to tie to anything to use Firebase, because you can always just do HTTP Ajax XML request calls to a server, and we cover these topics in the advanced Phaser course, which is currently on pre-sale at the moment because it's not ready yet. So 2 modules are out, and they cover how to integrate with Firebase. But if you've used Firebase, it's without React. It's really just Ajax calls. So that's you can add anything here. All this is JavaScript, and we're modifying the canvas on a browser. So you can integrate with whatever you want. You can create your own backend. You can use local storage to save your game progress. You can use any cool API or library that you find. There's actually an example that's integrated with Ionic. That it's if you search, I think it's called like Ion Phaser, and it's code that's for sale in the Ionic marketplace, or in Gumroad as well. I think it's like $15, and that one it comes with like an Ionic project with some Phaser games inside. Yeah, so it definitely can be done. Oh, yeah, I'm not using the autocompletion plugin. There is one though. I haven't tried it. The reason why the autocompletion seemed so smart was because I also had the completed file open as well, so it was grabbing it from there. Sadly, it's not as smart. It's my understanding that the WebStorm and also Visual Studio can have pretty good integration. I think you need a TypeScript definition file, which comes with Phaser as well, and then you can have that smart autocompletion. Regarding your question on the Intel XDK, so from what you showed us with the Intel XDK, I did not see anything about native desktop builds. Does it tie with the Intel NWS? I'm not familiar with Intel NWS, NW.js. What I can tell you is the Intel XDK, that's the build on the cloud. I don't know if they've added over the last maybe 3 months that I haven't checked, like the latest sort of things that were added, but I don't know if you can also tie to a locally installed Cordova instance. Maybe you can now, but to my understanding it's just building in the cloud. But then again, you can use all the other stuff and just build it yourself in the command line.